we solved linear systems by graphing them. So now let's go ahead and let's try solving them using substitution. And really what we're going to do here is we're just going to use algebra to figure out where these two lines meet. All right, well, let's start with a pretty basic one. So we've got y is equal to 5, and then we've got also that we've got 3x plus y is equal to negative 16. All right, now we could use a graph to do this, but I want to show you this idea of substitution. Since I already know that y is 5, right, and I already know here y is equal to 5, I can just plug this in. So I can say 3x plus whatever y is, in this case it's 5, is equal to negative 16. Okay, and then I can go ahead and solve from here. I can say 3x plus 5 is equal to negative 16. I'll subtract 5 from both sides. I get 3x is equal to negative 21. Divide by 3, and I get x is equal to negative 7. And so then I know that when x is negative 7, y is going to be 5. Okay. I can go ahead and check this again. So let's do 3 times negative 7 is negative 21. Negative 21 plus 5 does, in fact, equal negative 16. Okay. Now this is a very basic substitution. Okay, this is when you do when you just have a simple number, you plug it in. We've been doing this for a long time. So let's take a look at it when it's a little bit more complicated. So now I have y is equal to 3x plus 2. Okay, well, if I know what x is, this is just some number, right? Just like on that previous one, we had y is equal to 5. Well, here we have y is equal to this thing. So what I'm going to do here is I'm just going to go ahead and I'm going to substitute in what y is. So instead of y here, right, I'm going to use this y, which is equal to all of this. So I'm going to plug in, instead of y here, I'm going to say 2 times 3x plus 2. Which is equal to 11. Okay, and the reason I can do this is because this y here is the same as this, right? This represents the same number. Well, and I get this number by doing this, so I can plug this in here. All right, and then I'm going to go ahead and I'm going to distribute. So I get 6x plus 4 is equal to 11. I'll combine terms. So I get 7x plus 4 is equal to 11. Subtract 4, I get 7x is equal to 7. So x is equal to 1. Okay? And now what I'm going to have to do is I'm going to substitute back in x is where x is equal to 1, and I'll substitute that back in here. And in fact, I'm going to use this first equation, y equals 3 times 1 plus 2, because all I have to do is evaluate. Okay, and this other one I'm going to have to multiply, then subtract. More mistakes are likely to happen. So here we do. 3 times 1 is 3, plus 2 is 5. So 1 comma 5 is my solution. So let's go ahead and let's check it for each of these. Okay, so I've got y equals 3x plus 2. So we're going to say y is 5. So if I plug 3 times 1 plus 2, that works. Okay, and then let's try here. X is 1, and then 2 times 5 is 10. 1 plus 10 is 11. It works. Okay, so that's the basic idea. And we've done some of these last year, and hopefully it will make a little more sense this time. I find the substitution tends to be a little confusing, especially the first time, but hopefully the second time it makes a lot more sense. Why don't you go ahead, you try doing this one, okay? And if you get stuck on where to start, I'll go ahead and give you a clue, and then you can pause it again, okay? So go ahead and try it. All right, well, let's go ahead and let's say we want to solve this by substitution. The nice thing is, well, what we're going to need to do here is we're going to need to make one of these equal, right? I don't know if x or y equal to anything right now, but this first one to me looks x minus y is equal to 3. It looks like it's a pretty easy one to transform. So let's go ahead and if we say x is equal to, and then I'm going to add y to both sides, right? Or take this negative y and put it on the other side. So I'm going to get x is equal to y plus 3. Okay, well now I can just substitute that here. So what I'm going to do is I'm going to say y plus 3 plus 2y is equal to negative 6. Okay, and then from here I can just combine my y's, and I get 3y plus 3 is equal to negative 6. So I know 3y is equal to negative 9. So I'm going to get y is equal to negative 3. Oops, I don't need to circle that yet. And then I can go ahead and take y and plug it back in. So I'm going to plug it back in. We'll do it in that first one, in fact. So we'll do x minus negative 3 is equal to 3. So this becomes adding. So x plus 3, so I'm going to subtract, so I get x is equal to 0. So I should get 0, comma, negative 3. All right, well, let's check it. Okay, so if x is 0, then this has to be, if x is 0, then negative 3 is equal to 3. That's correct. Okay, and then if x is 0, then 2 times negative 3 is negative 6. Okay, it works. Okay, now let's go ahead and I'm going to redo this one. And let's say, we'll go ahead and we'll solve for x here. So let's say I say x is equal to negative 2y minus 6. Okay, so then I can take this thing here and plug it into that first equation. So I'm going to say negative 2y minus 6 minus y is equal to 3. Okay, and I get negative 2y minus y is negative 3y minus 6 is equal to 3. Add 6 to both sides. Negative 3y is equal to 9. Divide by negative 3y is equal to negative 3. Okay, and from here we can do it again, plug it in, and I'm going to get 0. And so I'm going to get 0 is negative 3. I get my same answer. Okay, that's another way of doing it. Third way, let's say we wanted to solve for y over here. So let's say, so for this one we say, maybe move the x to the other side. So you get negative y is equal to negative x plus 3. So then I'm going to need to multiply everything by, I can't have this be negative 1, so I'm going to multiply everything by negative 1 or make everything the opposite. So I get y is equal to x minus 3. Okay, and then I'm going to plug it into here, right? I can't plug it back into the same one because what's going to end up happening is I'm going to get 0 is equal to 0. That's not going to help me because everything is going to cancel out because it's the same equation plugging it in. So you have to plug it into the different equation. So I'm going to plug it in here. So x plus 2 times whatever y is, and we know that y is x minus 3. So x minus 3 is equal to negative 6. And I can get x plus 2x minus 6 is equal to negative 6. Add 6, or let's do 3x minus 6 is equal to negative 6. Add 6 to both sides. You get 3x is equal to 0. X is equal to 0. And we know from there, if I plug it in, if x is 0, then y has to be negative 3 in either one of those equations. So I'm going to end up with the same thing. So it doesn't really matter which one you do. As long as you do the steps correctly, you're going to end with the correct answer. Okay, let's try another one here. Whoops, nope, that's not what I want to do. Did I miss one? No, that's it. That's everything. So, very basic. Just bring these samples with you to class, and we will go ahead and practice more tomorrow. All right.